Okay, so we want to set up the integral to find the area between y equals x squared minus 2x minus 1 and y equals 2/3 x from x equals 0 to x equals 4. So the first thing that we really want to do when I have these types of problems is graph them to between 0 and 4 in this case. So just kind of how we did here, where we were graphing the function between x equals -1 and 2, we're going to do the same thing here. Now, one problem happens here that this one, and I'm going to call this one my green one. This one is really difficult for me to figure out what exactly it looks like. It is a parabola, but graphically it's not as easy to figure out what the parabola somewhat looks like. One way that you can do is you can try to complete the square and find the vertex, but that might take a while. So here is where you might want to use the table function. So the first thing that I'm going to do, that's going to be my green one. The other one I'm going to call my red one. Okay, so what I'm going to do is I'm going to graph both of them first, and I want to graph them between 0 all the way until 4. Okay, 1, 2, 3, 4. Okay, to see what these kind of are going to look like. Now this one's really easy to find, the red one. The red one's not bad because it's just a slope of a line. Pretend that this is the x-intercept is 0. And then here it's just going to go up 2 units, up to over 3. Okay, so this one wasn't too bad. Okay, so the graph is going to look something like this. Whoops, I messed up. So the graph will look something like this. If I can get this to work. Okay, so it's going to look something like this. Okay, not quite sure, but it'll look something like that. Okay. All right, now what I want to do is I want to go ahead and graph y equals x squared minus 2x plus minus 1. Okay, and the way that I'm going to do that is first I'm going to go ahead and put this into my table function. So I'm going to use my table function from my calculator here. So I'm going to click on table, then click on edit function, and I'm going to put in x squared minus 2x minus 1. Okay, so on start, I'm going to put in 0 because that's where it's going to start, and my step is going to be 1, and I'm going to go to calculate. Okay, so if you look here at your table function, you says that when x is equal to 0, my y is going to be -1. So here's -1. When x was equal to 1, I'm going to get a -2. Whoops. Oh no, that's right. Okay, when x equals 2, I'm going to go back to -1. When y equals 3, when x equals 3, I'm going to get x equals 2. And when x equals 4, I'm going to get y equals 7. Okay, so it's going to look something like this. So my graph will look something like this. All right. So now, since we want to figure out the area, and I'm going to color that blue, we want to find the area between these two curves. We can see that the area is here, between these two graphs, and also here between these two graphs. Okay, so in order for me to find the area, so area is just going to be equal to the integral from a to b of my upper function minus my lower function. Okay, now in this case, my line is my upper function between 0 and 3. That is where my graphs tend to where y equals what 2/3 x is higher. So my first one from 0 to 3, okay, so my integral from 0 to 3, my upper function is going to be 2/3 x, and then I'm going to subtract it from my lower function, which is going to be the parabola, x squared minus 2x minus 1 dx. Okay, so that's my first part. This is my area number 1. Area number 1. Now my area number 2 is going to be this one. Okay, so here's area number 2. Because we're still not done, we have to go all the way to 4. So now here, my parabola is much higher than my red one, so it's going to be plus the integral from 3 all the way to 4 of my green function, which is just going to be x squared minus 2x minus 1, minus my lower function, which is just going to be my red one, which is 2/3 x. Okay, 2/3 x dx. Okay, and then from here you can just basically solve it. You don't need to solve it since we just wanted to set up the integral, but this is just basically the answer. So it is a little bit more involved, but you need to figure out where exactly are these two going to cross. And for the exam, it will be very simple. You don't need to solve a really complicated one, because usually if you want to find this intersection point, what you got to do is set both of the equations equal to each other, like x squared minus 2x minus 1 has to equal to 2/3 x, and you have to solve this. And for this one, you actually have to use the quadratic formula. But the problem will be nice enough that you will be able to find where the intersection point is in the calculator. So that's it.